All right, so here's the plan for the week. Obviously, today is our A block day. You can grab the warm-up right from there if you want on that module page. This is week 8, which is, again, crazy to believe that we are at week 8 of this distance learning, but that's where we're at. We're going to do the warm-up, and then we're going to do the solving equations, and then your homework tonight is the P1 homework. Remember that we've switched to now it's the PDF. So basically, it's the chapter from the calc book. So if you go to that module, if you go to the module that is the chapter P, at the very top, there's a new calc chat link because this is a different book. That's where you can find the answers to the questions. And then there's also a link to the entire PDF of the entire, like all the different sections, so that if you want extra practice, they're there. Because what we're going to do is really minimal, like on each of those, like I kind of grab one of each kind of problem. And that's what your homework is, but there's lots more problems if you need the practice. They're on that big chunk of the PDF, so that's at the top of the module for Chapter P. We're going to do P2 on Wednesday, P3 on Friday, or no, sorry, P4, because P3 is plotting points. I have faith that you can plot an XY coordinate. P4 is on Friday, and then that's those 3 sections that will be 4 sections, because 10-1 will be on your last test, which is going to be next Wednesday, and that will be it as far as assessments go. And then we have one more week in which I'll do a review for a couple more sections, just so that I know you'll see stuff again next year on, but you'll be done with your major grades. All right, so here's the warm-up. Remember in 10-1 we did the XYZ coordinate grid. So this one says plot each point, then find the distance and midpoint between the points. So if I wanted to plot the point A to -5, 6, I want to look where my axes are labeled. So I will try to keep this consistent from here on, because I think that's part of the confusing part. Your X is on the front. So if it's coming from me, I'm going to try to make it so that it's this way. X is on the front, Y is on the right, Z is on the top. So if I want to move 2 on the X, I'm going to come forward 2, 1, 2, and I'd be here. If I want to go -5, that means I'm going to the left 5, 1, 2, 3, 4, 5. I'd be all the way over here. That would be 2, -5. And then up 6, 1, 2, 3, 4, 5, 6. And that would be point A. Point B, 1, 0, 2 would be forward 1, not right or left at all, and then up to 1, 2. And we talked about it last week, but remember, these are not going to be exact and align with your vertical axis, because there's a tilt on your graph. If this was flat, first of all, if it was flat, it wouldn't be 3D, but if it was flat, where the X and Y is perpendicular, and there's nothing coming forward, that's when you would see it exactly aligned with your vertical axis. But because there's a tilt on it, if you could kind of picture what would it look like if there was a tilt, the tilt is going to cause it to not be perfectly aligned with your y-axis coordinate, so our z-axis coordinate. Okay, so that's the plotting of the point, and then we did distance, which is the same as the distance formula that we're used to, except it's x, y, and z. So here's my x1, my x2, my y1, my y2, and my z1 and my z2. And actually the order there doesn't matter which ones are the ones and the twos, as long as they're both in there. So I would do the square root of 1 minus 2 squared plus 0 minus a -5 becomes +5 squared plus 2 minus 6 squared. Hey, Gia, can I just see your camera real fast, please? Thank you. Okay, so -1 squared plus 5 squared plus -4 squared. 1 plus 25 plus 16. 26 plus 16. 42. That's 2 and 21, which is 3 and 7. It doesn't break down any further, so that's the distance. And then the midpoint, we're just going to add the 2 x's, divide by 2, add the 2 y's, divide by 2, and add the 2 z's, divide by 2. And this time one of them gets simplified. This would be 3 over 2, -5 over 2, and 4. questions on any of that? So the graphing, most likely on your test, I haven't made it yet, but most likely on your test, I'll give you the graph and you're going to give me the coordinate point. Kind of like that first example, just so that we can be exact. All right, number 2 says find the standard equation of the sphere whose diameter has endpoints 2, -4, -5, and -4, 8, 3. Then identify the center and the radius. So I know for a sphere, this is my standard form of my equation. X minus h squared plus y minus k squared plus z minus j squared equals r squared. And in order to find the standard form, I need to know my center and I need to know the radius. So because I'm given the endpoints of the diameter, I can find the center by finding the midpoint. So I'm going to do the midpoint because that's going to be my center. And it would be negative, or it'd be 2 plus -4 over 2. It'd be -4 plus 8 over 2. And it'd be -5 plus 3 over 2. -2 over 2, 4 over 2. -2 over 2. So -1 to -1 is my center. That's my h, my j. I mean my h, my k, my j. And then there's 2 ways to get the, well, I guess there's 3 ways to get the radius. I could either find the distance from the endpoints of my diameter and cut it in half, or I could find the distance from my center to one of those coordinate points, or I can take one of those coordinate points. So let's just say I grab this first one and the center and plug it in to the equation to find the radius. You can do any of those 3. So let's say I do that. This is my h, no, this is my h, my k, my j. That's important. And this is my x, my y, my z. So I would do 2 minus a -1 becomes +1 squared plus -4 minus 2 squared plus -5 minus a -1 squared equals r squared. 3 squared plus -6 squared plus -4 squared. 9, 36, 16. So that's 45 plus 16, or 61. That's your r squared, which means this is my center. The radius is the square root of 61, which is prime, so it's left as that. And then the standard form is x minus a -1 plus 1 squared plus y minus 2 squared plus z minus a -1 plus 1 again squared equals 61. And there's the standard form of the equation. Actually called the Prereq Chapter. So it takes you through a lot of stuff that, this is like Algebra 2 skills that you should have seen again this year. So this is like round 5 on a lot of this stuff. This should be review. So I'm just going to go through like one of each different kind of problem. I didn't really do a lot of notes here because this is stuff we've been doing. Hopefully that just the examples will jog your memory. And then I kind of just picked a couple of problems, one of each different kind. So in P1, it's solving equations. So this is a lot of different kinds of equations. Fractional equations, radical equations, quadratic, all that stuff is in this section. If there's one thing that you need to focus on, then pick it and make sure you do the extra practice problems on it. But hopefully this is, like I said, this is a review, and hopefully this is just like a, oh, I forgot how to do this, but now I remember kind of a day. So the first one is fractional equations. When you're dealing with equations that have fractions in them, the easiest thing to do is to eliminate the fraction by multiplying by the least common multiple. So you want to look at the denominators. You want to say, what do all of those denominators go into? Multiply everything by it to get rid of those. And it starts with just numbers in the denominator, which should be kind of easy. Then we get into variables in the denominator. So we actually haven't done this in a while. It's been like since maybe the first chapter that we've seen the ones that have them in the denominator. And then we had them with the rational graphs. But notice that I also add on there that to make sure that you check the answers with variables in the denominator. So the ones that have a variable in the denominator, like b, you always want to make sure that you check your answers so that you can eliminate an extraneous root, or a root that looks like it works but doesn't work because it would make your function undefined. So if I zoom in on just the first one, it says 3x over 8 minus 4x over 3 equals 4. So I want to just look at 8 and 3 and say, okay, what do they both go into? Which would be 24. Multiply everything in the equation by 24. And the biggest mistake people make with these is forgetting to come across to that 4. So make sure you don't forget. When you multiply by that 24, you're going to cancel out your denominators. It's the whole point of that process. So 8 goes into 24 3 times, which means I'm going to multiply 3. So really I'm going to write it out just so you can see it. I'm doing this step, but I'm going to do it in my head. So the 8 goes into 20, that should be 24, 3 times, and that becomes 9x. 3 goes into 24 8 times, and that becomes 32x. And then 4 times 24 is 96. Then I do 9 minus 32, and I get negative 23x equals 96. Divide both sides by negative 23, and x is negative 3. These are also easy to plug in. I can plug in 3 and can plug in 3 and double check that my answer works so that I get a balanced equation. Questions on that one? Okay, then this next one, which should be B. I thought the chair was gonna tip, and in my head I'm thinking it's gotta be Kevin, but I turn around and I don't see you. It's not funny. It's too early for this crap. Sorry. It's my husband. Likes to mess with me. Okay. So 6 over x minus 2 over x plus 1 equals 3 times x plus 5 over x squared plus 3x. So the first thing you gotta do is when you've got variables in the denominator. Did I not do that right? You're totally right. This should be... That does not work. That does not simplify. There you go. You can leave it like that, or you can put it into mixed number form. So you could do 96 divided by 23. Oops. 4. So it'd be 4 and 4 23rds, but it'd be negative. Okay. Yeah, you can leave it as long as it's reduced. So either one of those works. Okay, so B, you've got variables in the denominator. What you want to do first is go through and make sure that they can't be factored. So x is obviously as factors as it gets. X plus 3 is, but the next one would be x times x plus 3. So when I factor that out, that's what that looks like. Now when I'm looking at the least common denominator, or least common multiple of my denominators, you want to look for each of the expressions and list all of them that are there. If there's one there that's squared and not, then you take it to the highest exponent. So the least common denominator here is x times x plus 3. So I'll multiply those times each of the terms again in my equation, x times x plus 3. And when you do that, x plus 3 times 6 over x minus x plus 3 times 2 over x plus 3 equals 3x plus 5 over, I'm going to keep it factored, times x plus 3. These should cancel. The whole goal is to cancel out my denominators. So x and x cancel, and I get 6 times x plus 3. X plus 3 cancels here, minus 2x equals the x and the x plus 3 cancel here, and it's just 3 times x plus 5. Now you've got to distribute that 6 to both of those. 6x plus 18 minus 2x equals 3x plus 15. 4x plus 18 equals 3x plus 15. Subtract the 3x. Subtract the 18. X equals negative 3. So what happens in these cases is if there was a variable in the denominator, which is happening here, we have to check to make sure this isn't an extraneous root. So if I take that negative 3 and I plug it into x, it's fine. I can divide by a negative number, not a problem. But if I take that negative 3 and I plug it in here, I'd get negative 3 plus 3, and I end up with a 0, and 2 divided by 0 is undefined. Which means in this case, we actually have to rule out our answer and say no solution. If there was 2 answers and only one of them would make it undefined, then I cancel out that one, but I keep the other one. But in this case, they would both, the only one that I've got doesn't work, okay? It's called an extraneous root. So any one that has a variable in the denominator, you've got to make sure you check your answers. Questions? on that one. Those are fractional equations. Okay, then comes 2 is quadratic, but we're solving these using the even root property, which we've done a lot. Okay, even root property says when I go to square root the other side, don't forget that I have to do the plus and the minus. That's the whole idea behind the even root property. So if I look at 9x squared equals 36, you could divide both sides by 9, and I get x squared equals 4, and then I have to square root both sides, but when I square root that 4, I'm going to put the plus and minus in front of it, and I get x equals plus and minus the square root of 4, which is 2. And there you have 2 answers that you can check. If I were to plug positive 2 back in here and square it, I'd get 4. 9 times 4 is 36. If I plug negative 2 back in there, I square it, I still get 4. 4 times 9 is still 36, so that's why there's 2 answers there. Questions on that one? All right, then comes the next one, which is still even root. It just has a couple of different steps. So the first thing we got to do here is add the 27 to the other side. Then square root both sides, putting that plus and minus in the front of the 27. So I'd get 2x plus 3 equals plus and minus. Root 27 is 3 and 9, or 3 root 3. Then subtract the 3. So you can actually rearrange that so it's negative 3 plus and minus 3 root 3. Last step, divide by 2. So really there's 2 answers here because of that plus or minus. One that says negative 3 plus 3 root 3 over 2. And one that says negative 3 minus 3 root 3 over 2. If this was a question on your test, probably just because the format is kind of difficult, I would probably keep it as this one would be a multiple choice question, and it would probably be left as the plus or minus, so you can kind of like think about that in your head. On your PDF homework, I'll take either answer. You can either keep it all together with the plus or minus, or you can separate them out as 2 answers. If I was able to square root 27 and make it a simplified, like make it a number, then I would have to continue to get those 2 answers. So if it was a perfect square that you could simplify, you'd have to make sure that you do, and then break it down to the 2 answers. Questions on that one? All right, next up is complete the square, the ones you have used a lot. Okay, so we're going to solve this by completing the square. Notice it's quadratic. So quadratic, there's a lot of different ways that you can solve. You can solve by doing what we just did, the even root property. We could solve, which is only if it can be put into standard form. This, which is complete the square, quadratic formula, which we're going to get to in a minute, factoring, those are all ways to solve quadratic equations. So this one is complete the square. Remember, we're going to group the first 2 terms together. You're going to bump the 9 to the other side. Now we got to take out the 4. And it comes off of both of those terms, both the x squared and the 5. Now to find that middle term, and this is why we picked this, is because they're not always pretty. We've been kind of doing a little bit easier numbers. But if I take that 5 over 4, divide it by 2, which is the same thing as multiplying by a half, I get 5 over 8. Then I square it, and I get 25 over 64. And that's what I have to add in here. And that's what I would normally add to the other side, but before I do that, I have to multiply it times 4. So 4 goes into 64 16 times, and I'm adding 25 16ths. Now I'm going to simplify the left side. I'm going to keep the 4, square root the first term, which is x, square root the 25 over 64, which is 5 over 8. Take the sign from the middle, which is my minus, put it in the parentheses and square it. And then I've got to add 9 and 25 16ths. So 9 over 1 becomes 144 over 16. 144 plus 25 is 169 over 16. Now I gotta solve it. So I want to divide by 4 or multiply by a fourth. This becomes 169 over 64. Square root both sides, putting that plus and minus on the right side, and I get x minus 5/8 equals plus and minus the square root of 169, which is 13, over the square root of 64, which is 8. And then my last step here would be to add the 5/8. But there's two answers here, remember? There's 13 plus 5 over 8, and there's negative 13 plus 5 over 8, which is 18 over 8, or 9/4, and negative 8 over 8, or negative 1. So my answer is negative 1 and 9/4. Questions on that one? All right. Next one. Quadratic formula. So it's been a while for us since we've done this, and this is definitely something that's important. This is something that will show up on standardized tests, and they expect you to know it. And that is this. X equals negative b plus and minus the square root of b squared minus 4ac all over 2a. So for this, first of all, we want to look at our equation and we want to get it into quadratic form. So we want the x squared to be first. Negative 49x squared plus 28x, and then bring that 4 over, minus 4 equals 0. So A is negative 49, B is 28, and C is negative 4. And I get the square root, or sorry, I get negative B, which is negative 28, plus and minus the square root of B, 28 squared, minus 4 times A times C, all over 2 times A. Negative 28, plus and minus the square root of 28 squared, 784. 4 times 49 times 4, negative 784. Over 2 times negative 49, which is negative 98. So negative 28 plus and minus, this would be 0 over negative 98. If this was a number other than 0, we'd simplify it as much as we can, but with 0, obviously, we can simplify. I get negative 28 over negative 98, which becomes positive 28 over positive 98. 7 goes into both of these, 4 and 14, 2 goes into those, 2 and 7. So my answer is 2/7. These are all going to be kept exact. So if you're thinking about using your calculator to help you out with it, obviously that's totally fine. You can use it for like a 28 squared. Just keep in mind that you're not going to want to type that all in to get your answer as a fraction. I mean, as a decimal, it's going to be left as an exact fraction. Questions on that one? All right, next up is solving by factoring. So some of these questions, which if it asks you to factor, it's going to be able to be factored. Obviously, some of these questions will be prime and they wouldn't be able to be factored. And those you'd have to use complete the square or quadratic to solve them. But for these are going to be factorable. If they say to solve by factoring, you're going to be able to factor it. So there's all the different kinds of factoring. You could see difference of two squares, you can see three terms like a trinomial where you have to find the factors of the last that sum to the middle. And then you've got some where there's four terms. Those are the ones you're going to factor by grouping. And then ones like B where you've got a higher exponent than you're used to, which looks scarier than it really is. So if I start with A, there's four terms here, which means I want to factor by grouping. So I'm going to group these and these. Notice that the negative sticks with the x because that negative is on that x. If it was a plus, it wouldn't matter, but the negative has to stay on that x. So then from the first set of the parentheses, we could take it an x squared, and I get x minus 3. From the second set of parentheses, if I leave it as it is, the signs are off. If I take it a -1, it flips those signs. So now what's inside the parentheses is the same. That gets taken out because that's the greatest common factor. What's left over, x squared and -1, gets grouped together. And then you want to see if it's factorable further, and it is. X squared plus or minus 1 would be x plus 1 and x minus 1. Now, if any of these three parentheses was 0, it'd make my entire row 0, which is why we can split and solve these. So I'm going to set each of these equal to 0, and I would get x equals 3, x equals -1, and x equals +1. And those are your three answers. Mary Angel, can I see your face? Thank you. All right, then the next one, so this has three terms, which is where we normally look at the last one and we sum it to the middle term. The difference this time is we're raising it to the fourth. So as long as that first one is an even number and the second one is half of it, then you factor it almost the same way we normally factor, except that we normally put x's here. And now we're going to put half of my first exponent there. So if it was x to the 6th, it'd be x to the 3rd and x to the 3rd. If it was x to the 8th, it'd be x to the 4th and x to the 4th. It's x to the 4th, so I do x to the 2nd and x to the 2nd. And that variable should match this middle term. That's how you know you did it right. Now I got to look at -8 and +7. And I want to ask myself, what are the factors of -8 that sum to +7? And that's a +8 and a -1. So one gets the +8 and one gets the -1. I can double check that this matches what I originally had by multiplying the outer and the inner. So I'd get -x squared plus 8x squared. And that gives me 7x squared, which matches. So I know I factored it correctly. So now I'm here. X squared plus 8 can't be factored any further because it's a plus. But x squared minus 1 can be x minus 1 and x plus 1. Now I can set them each equal to 0. And I get x squared equals -8. X would equal plus and minus the square root of -8, which is not a real number. So I ignore it. For the other ones, I'd get x equals -1 and x equals +1. So my two answers are -1 and +1. We're not doing imaginary numbers. That would be an I for the 8, the square root of -8. We're just using real numbers. If that was my only solution, then my answer would be no real number. But obviously I have other answers this time. Questions on that one? Okay, 10 is radical equations. So now we've got equations that start with a square root in them, and we've got to get rid of the square root. So if I've got a square root in my in my question, then I'm going to get that square root on the side by itself. So in something like this, make sure square root is on the side by itself. That's the easiest way to do it. And then I'll square both sides of the equation. If it's a cube root, I want to do the same thing. Get the cube root on the side by itself, and then cube both sides of the equation. And then we'll get to the one that has the fractional exponent like C. These are also ones that you have to check answers because they have a restriction on the domain. If you think about, when we think back to domain restriction, it was all real numbers. Like we didn't have to worry about domain restrictions unless we had a variable in the denominator. So like that first example, we said if there's a variable in the denominator, we got to check the answer. And if there's a variable under a square root, there's variables under the square root for these. So these are the ones you have to check your answers to make sure they work and there's not an extraneous root. Okay, so I'm going to look at A, which says the square root of 5 minus x minus 3 equals 0. The first thing I'm going to do is add that 3 to the other side, getting my square root on the side by itself, and then I want to square both sides of the equation. The square of the square root cancels out, leaving me with what's underneath, and then 3 squared would be 9. Solve it by subtracting the 5, negative x would equal 4, and multiply or divide by negative 1, and x is equal to negative 4. But again, I want to check it. I don't have to check it full out. I mean, it would be helpful to check it full out and make sure my answer's right, but what I really need to check to see is if I plug that in, am I going to get a negative underneath my square root? So if I get 5 minus a negative 4, it becomes plus 4, and I get 9, and I can square root the 9, so I know I can keep this answer. It's not extraneous. If I go to B, again, first thing I want to do is get that, this time cube root on the side by itself. So I'm going to leave the cube root of 4x minus 3 equals, and I'm going to bump the negative 2 to the other side. Now I'm going to cube both sides of the equation. Cube of the cube root leaves me just what's underneath. Negative 2 times negative 2 times negative 2 is negative 8. Add the 3. And divide by 4. Here's the answer, but I've got to check it. So if I take negative 5/4 and I plug it in underneath, these cancel, but I get negative 5 minus 3, and I get the cube root of negative 8, which is negative 2. So you can plug it in to check it, but actually with a cube root, you're never going to have the issue because a cube root can be positive or negative. So really you're checking ones that have square roots or fourth roots, that kind of thing, to check to see if it's extraneous. And again, if it was something underneath, like if I was square rooting that negative 8, it wouldn't work. So I would eliminate that answer. That would be an extraneous root. This time it's fine. All right, fractional exponents, and it's been a long time since we did these, okay? So a fractional exponent, when you get rid of it, this is really, if I wrote this out as a radical, the 2 becomes the index. So this would be the square root of x plus 3 cubed. That's what that would look like, right? So the bottom slides over to become the index, the top drops down to become the exponent. But I don't need to do that because all I want to do is get rid of that. So I'm actually going to raise both sides to the reciprocal. So the reciprocal of 3 over 2 would be 2 over 3. And so I'm going to raise both sides to 2 over 3, whatever the reciprocal of the exponent is. And it's going to eliminate from the left side, leaving me x plus 3 equals, but then I get 8 to the 2/3. Now I got to rewrite that in radical form. So this is the cube root of 8 squared. Or the cube root of 8 squared underneath. It doesn't matter where that squared goes. I tend to cube root it first because it'll be smaller. So I get x plus 3 equals, the cube root of 8 is 2, and 2 squared would be 4. Then I'm going to subtract the 3, and I get x equals 1. Since it's a square root, I want to check my answer. 1 plus 3 to the 3 halves would be 4 to the 3 halves, or the square root of 4 raised to the 3rd. As long as you can square root the number underneath, which we can square root 4. My answer's fine. I'd keep x equals 1 as the solution. Questions on those? All right, last one is your absolute value equations. So when we're solving absolute value equations, we got to get rid of the absolute value by setting whatever's inside that absolute value equal to the positive and negative version of the number on the other side. So we want to, again, make sure that that absolute value is on the side by itself first. and then get rid of the absolute value by setting equal to the positive and negative numbers on the other side. So in example 7, the absolute value is already on the side by itself. If it wasn't, I would move whatever on the outside to do that. And then I'm going to set whatever's inside the absolute value equal to the positive and negative version of that number. So 13x plus 1 would equal negative 12, and 13x plus 1 would equal positive 12. And then I'm just solving it twice. Subtract the 1, 13x equals negative 13, divide by 13, x equals negative 1. 13x would equal, subtract the 1, 11, and x equals 11 over 13. So the two solutions I'd have here are negative 1 and 11 over 13. And again, we can take those and plug them into check with extra time. All of these, you can take the time to plug them in and check. Questions on that one? So there's a lot of different types of problems in this section, but we've done them all, and you did them in Algebra 2. You've done them again, right? So hopefully this is like, and most of them in Algebra 2, Algebra 1 as well. Hopefully this is entirely review, but it has been a little bit of time since we've done things like absolute value and square roots and all that good stuff. So hopefully this helped jog your memory, because those are definitely skills you're going to need to survive calc. And you're going to see them again, obviously, on any kind of standardized test. Questions for me on anything we talked about today? So again, moving forward in the week ahead, this homework assignment, which is that PDF, is going to be due on Wednesday. And then Wednesday we're going to do P2, which is a little bit shorter. This one's the longest one. And then you'll do homework due Friday, which P2, and then we'll talk about P4, which is the graphing, and which is reviewing like symmetry and x-intercepts and all that good stuff. And then next week will be the last test, and it's going to cover P1, P1, P2, P4. And then we're going to do, I think it's 1 or maybe 2 more sections to review, like just the week after that, when I see you the week after that, which is kind of, that's it. We've got like 3 weeks left, which is crazy. And I'm sure you guys are counting down the days. I know I am. All right, folks. If you have turned your camera off, if you'll turn them back on.